Yesterday we discussed about the emission of electrons. Emission of electrons. How many types are there? 4 types. What is the first one is equal to thermionic emission. Second one is the photoelectric emission. Again, third one is the field emission. Fourth one is the secondary emission. For all cases, we can remove the electrons from the metal surface only. So remove the electrons from the metal surface. So especially second point of view is the photoelectric effect. So today I am going to explain the photoelectric effect. Photoelectric effect. Photoelectric effect. The emission of electrons from the metal surface. The emission of electrons from the metal surface the emission of electrons from metal surface when illuminated by electromagnetic radiation of suitable frequency is known as photoelectric effect. Already yesterday we discussed about this definition also. Same thing here. It was observed by the photoelectric effect was first observed by the Hertz. Again, after that, again, next one is again Lenard's, again Halwach. Again, they did some experiments. So about this photoelectric effect. So actually what happens means this is the one metal surface. So this is the one metal surface. This is the incident radiation of light having the suitable frequency. So not all frequencies here, suitable frequency. So whenever suitable frequency of the light, suitable frequency of the radiation is incident on this metal surface only. So hence here the electrons are produced only. So electrons are emitted from this metal surface. So electrons are ejected from this metal surface. So hence this phenomenon is known as a photoelectric effect. Okay. So what is the meaning here? What is the definition? The emission of the electrons. From the metal surface when illuminated by again electromagnetic radiation of suitable frequency. So this one is a compulsory suitable frequency. So what is the meaning of suitable frequency? What is the technical name? I will explain later also. So suitable frequency is known as a photoelectric effect. Okay. So who was discovered means here first it was discovered. After that again here Lenard's and Halwach's they did some experiments. Okay. Again this photoelectric effect. Suppose here this current to passes in an external circuit here. So due to the suitable frequency of the light is incident on this cathode. So this current is known as a photoelectric. So photoelectric current. So PEC, photoelectric current. That means the current to passes in the circuit. Here external circuit. So when suitable frequency of the light is incident on this emitter. So this current is known as photoelectric current. Again, next one more definition is equal to work function. This symbol is equal to W naught, or this is also one more symbol is equal to pi naught. So work function. Already yesterday we discussed about this work function also here. Once again this definition, work function. Here whenever suitable frequency of the light, suitable frequency of the light is incident on this metal surface only, so electrons are ejected only. So that means here so what is the minimum amount of the energy is required only. So what is the minimum amount of the energy is required? So to remove the electrons from the metal surface, so to remove the electrons from the metal surface, so that is known as work function. So the minimum amount of energy, the minimum amount of energy, the minimum amount of energy required to, so required to eject the electrons from the metal surface is known as work function. What is the symbol of this work function is equal? W naught. So this is equal to W naught. This work function depends upon the nature of the metal. So nature of the metal here. So different metals, different materials having the different work function over here. So what is the units of this work function is equal to here? Electron volt. Yesterday already I given this electron volt also here. Electron volt. Suppose in case of the cesium metal, this work function W naught is equal to here 2.14 electron volt. So this cesium is equal to minimum here. That value is equal 2.14 electron volt. Again, so maximum is equal to platinum. This work function is equal, this work function W naught is equal here. So 5.65 electron volt, 5.65 electron volt. So what is meaning of electron volt? What is meaning of the EV? So EV means electron volt. So what is the definition is equal here? The energy gained by the electron. The energy gained by electron. The electron again accelerated to the potential difference of 1 volt is known as electron volt. So what is the relation is equal here? So 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. So generally what is the unit of energy is equal to here? Joules. So what is the relation between the energy and again electron volt joules is equal to here? So 1 electron volt is equal to 1.6 into 10 power minus 19 joules. Okay, this is so electron volt is the unit of the work function. Simply here the electron volt is a unit of the fundamental particles only. So what is the meaning of work function is equal to here? The minimum amount of the energy means nothing but here the frequency also here. The minimum amount of the energy required to. So remove the electrons, required ejecting the electrons. So required to remove the electrons from the metal surface is known as work function. So this is the one definition here. Again, now in the definition here, so we are using the suitable frequency over here. Suppose here that frequency of the incident light is less than of suitable frequency, what happens here? The electrons will not be emitted over here. So this type of the frequency is known as, threshold frequency. So threshold frequency. This symbol is equal to here the nu naught. Threshold frequency symbol is equal to nu naught. Threshold frequency. Here the threshold frequency means for all incident light of radiation, for all incident radiations here, these photoelectrons will not ejected from the metal surface only. Compulsory one condition here, the frequency of the incident radiation, having the suitable frequency only. Suppose here this frequency is less than a suitable frequency, the electrons will not come outside only. So this type of the frequency is known as threshold frequency. So what is the actual definition means here? The minimum frequency of incident light. The minimum frequency of incident light required to remove the electrons from the metal surface is known as a threshold frequency. Same as this definition, but again here the frequency only. So the minimum amount of energy, the minimum frequency. So the minimum frequency of incident radiation, the minimum frequency of incident radiation, the minimum frequency of incident radiation to eject the electrons, from the metal surface, to eject the electrons from the metal surface is known as threshold frequency. Clear? First definition is the work function, second one is equal to threshold frequency. Again, next one is the threshold wavelength. The symbol is equal to lambda naught. Threshold wavelength. What about the relation between the frequency and wavelength? Directly proportional, inversely? Inversely. Inversely means this one is equal here, minimum on here. So this is equal to how much value? This is maximum on here. Same definition, but again this is the maximum. The maximum wavelength of the incident radiation to remove the electrons from the metal surface. The maximum wavelength of incident radiation to remove the electrons from the metal surface, is known as threshold wavelength. Okay? So actually what is threshold means here? Suppose here this is our house on here. We are entering into the house, again first step, this one on here. So this is equal to a door, okay? So that means here we are entering into this house, first step here. So this point is nothing but threshold only. So threshold means again the first door, okay? Same again. So in our exam also, NEET exam, sir, I got the marks is equal to 620 out of the 720 marks only NEET exam. So I got good marks also, but again, I got the maths in one subject, marks is equal to maybe 30 or 31 here. They will give medical seat here. So that means here I got 620 marks again the exam here. Okay, good marks and good rank also, but again I am not satisfied this one subject marks on here. So that means what is threshold marks is nothing but this is equal to 35, compass 35 only here. So those students will get again threshold marks only. Threshold is nothing but so minimum marks is equal to 35 only. So maybe physics, chemistry, biology, anything else here. The threshold marks is equal to 35 only here. So whenever students is more than threshold marks here, they are eligible to write NEET exam or maybe again seat also anyone here. Same this also here for all not again light, incident light here. The electrons not ejected only. Certain conditions, certain frequency is there. That certain frequency is nothing but threshold frequency. The threshold is nothing but same as minimum marks, minimum only. Okay. How much minimum is equal? Nothing but 35 also here. So physics pass is equal to 35 only here. Okay. Same this is threshold frequency means here the minimum amount of the minimum amount of frequency of incident radiation to eject the electrons from the metal surface. So that is known as threshold frequency. Same again, threshold wavelength means here the maximum wavelength of incident radiation to remove the electrons from the metal surface is known as threshold wavelength. So what is the equation is equal here? That equation is equal to E is equal to energy is equal to say. So this equation energy is equal to H nu. So this is equal to work done W, or W naught is equal to H nu naught. This is the one equation. The work done is equal to W naught is equal to H nu naught. So where W naught is equal to work function, H is equal to say Planck's constant, so nu is equal to threshold frequency. Again, so W naught is equal to Hc by lambda naught. So what is the lambda naught is equal to threshold wavelength. So W naught is equal to H nu naught, or W naught is equal to Hc by lambda naught. So what is H is equal to here? So H is equal to Planck's constant, C is equal to velocity of the light in vacuum. By simplifying this value is equal to here, so this one is equal to 12,400. So this units is equal to electron volt, and this lambda must be in angstrom unit only, compulsory here. So in objective point we have to use direct this equation only here. So W naught is equal to so 12,400 electron volt by W naught. But what condition here? This value is equal to electron volt only here. So this is equal to angstrom unit only. Clear these definitions? So one is equal to photoelectric current. First one is photoelectric current. Again, next one is the photoelectric effect. Okay? Who was discovered by the photoelectric effect means Hertz. Okay? Again, next one again further again experimental again here the Lenard's and Hall watches one. Okay? Again, in the last class we discussed about cathode rays. Again, next one is the electron, again E by M, nothing but specific charge. Again, next one is the electron charge also here. So compulsory you have to practice that scientist name also here. Okay, who was discovered by the electron, nothing but again who was discovered electron here? Thomson. So what is the value of the again E by M value is equal here 1.76 into 10 power minus 11 coulombs per kg. Again, next one again, what is the charge of the electron is equal here? 1.602 into 10 power minus 19 coulombs. Who was discovered by the charge is equal to say Millikan. And again, Millikan established one quantization of the charge only. That also completed here, basic here. Again, next one, photoelectric effect. So tell me what is experimental verification of this photoelectric effect. Next one, Lenard's experimental study of photoelectric effect. Lenard's experimental study of photoelectric emission, photoelectric effect. Experimental study of the photoelectric effect. So this is a evacuated glass tube. Glass or quartz tube. This is a C is a cathode. C is equal to say photosensitive cathode. So this is the emitter to emit the electrons only, hence it is also known as emitter. A is equal to anode. To collecting the electrons, so this is also known as collector. And W is equal to transparent window. Transparent window. Here V is equal to voltmeter to find out the potential difference between the cathode and anode, and again mu a microammeter to find out the current value in the circuit only here. So C is equal to photosensitive cathode. So A is equal to here metal anode. This also known as collector only here. Again next one. This glass tube is nothing but evacuated glass tube, or this is also here the quartz tube. This one is equal to W, again this one is equal to filter. Experimental study of the photoelectric effect by Lenard's experiment, Lenard's. Again. So one is equal to C, C is equal to cathode. This is also known as the emitter, to emit the electrons only here. Again A is equal to anode to collecting the electrons from the metal surface. So hence it is also known as a collector. Again W is equal to transparent window, transparent window. Again next one is equal to this RH is equal to reversing switch also here. So what is the useful of this reversing switch means here the same switch here the one time we can give into the positive potential to anode with respect to cathode. And again same switch again here the negative potential is given to the anode with respect to cathode only here. So that means here the for that necessary only here, so one time positive potential is given to anode with respect to cathode. Again next one again negative potential is given to the cathode, again anode with respect to again cathode only here. So that is a reversing switch also, reversing switch only here, okay? Okay. Suppose here the, so whenever the suitable frequency of the suitable frequency of the light, suitable frequency of the electromagnetic radiation, anyone here, electromagnetic radiation. So again, which is incident on this, so again cathode metal surface only. So now what happens here, so according to photoelectric effect here, so according to emission of electrons, what happens here, some of the electrons are ejected from this cathode only. So some of the electrons here. So now what happens here, this all electrons still not be at rest only here, they are trying to move towards to anode only. But again here the, so maximum of the electrons to come to the rest before reaching the anode only. So only high energetic cathode, only high energetic electrons can move towards to anode. So when here, suppose this one is equals half one switch, this is equal to tap key K. So first point is equals to K. First one is equals to K. So K is equals to open. K is equals to open. So what happens here? This battery is not in the circuit only, without battery only here. So only this part is equal. Only this part is equal. Okay, now without battery only. Okay, so without battery K is equals to open, not close one here. So the switch K is equal again off condition. What happens here? So whenever this light is incident on this metal electrodes of the cathode, so what happens is according to definition of the photo emission of electrons here, so electrons are ejected only, okay. But again here the maximum electrons again come to the rest before reaching this anode only. So maximum of the electrons come to the rest before reaching this anode only. But again, very few high energetic electrons can reach us to the anode. So after some time, what happens means here this is completely filled with electrons only here. So this region is nothing but space charge. Okay, space charge means here so whenever this tap key K is off condition, the switch K is equal off condition. K is equal to open only. What happens here? So what happens here? So whenever incident light on this metal electrodes on here, some of the electrons are ejected from this cathode. So what happens here? So very high energetic electrons can move towards the anode only. Okay, maximum what happens means they come to the rest again before coming to the anode one here. So after some time what happens is here. Suppose also coming this door one here. Again for outgoing there is no second door. What happens here? This classroom is completely filled with the students one here. Okay, all students coming from the only one door only here. Again outgoing, again there is no second door. What happens here? After some time it is completely filled with the students only. Same this also here this completely space is filled with electrons only. So this part is equal to space charge. Okay. So what happens means here so one electron coming to this electrons one here. So due to repulsion forces here some of the electrons can move towards the anode. Okay, that means here some current passes only. This type of the current is known as a photoelectric current only. So already I given the first definition one here. So what is a photoelectric current means here the current in the external circuit, this external circuit one here, the current in the circuit. So when here the suitable frequency of the light is incident on this metal surface only. So this type of the current is known as what happens is photoelectric current. Okay, so photoelectric current, this is the first point here. So whenever the switch K is equals open condition here, so this region is nothing but space charge. Okay, again next second point. Once right here, first one this is equal K is equal here open. So open is equal off condition one here. That complete region is nothing but space charge. Okay, again next one, second point. Suppose K is equals on condition here, K on means here this K is equals to closed only, switch closed only. And again here the anode is given by the positive potential with respect to cathode. Okay, so again anode is given by the positive potential. Automatically this is equal positive means what happens? Cathode is equal what happens here? This is equal here negative potential only. Compared to one is equal positive means second one is a negative potential. Clear this one here? Second point again, whenever the switch K is equals on condition, what happens here? Again here due to this battery here, this is equals plus is connected to anode only here. So with respect to anode, okay, automatically this cathode this is equals to negative one. So now what happens here? This all electrons can be repelled with again this cathode one here. Since this is equal negative charge one here. So negative charge on here. Okay. Again next one again what happens again here this is equals to positive charge on here. This all electrons can be attracted with this negative charge on here. So in the previous time I told one example here. All students coming from this door one here. So there is no second door is closed one here. What happens here? This classroom completely filled with the students one here. Again, the second door is open one here. Some persons calling here. Again, what happens? They can move towards to second door one here. Same, this also here, this anode is equal positive is given here. What happens here? So due to attractive of this positive potential and again electrons here, these electrons can be moved towards to anode one here. So what happens here? Again, this photoelectric current again increases only. In the previous case, what happens here? So only high energetic electrons can move towards the anode. So now what happens here? High energetic electrons over here. So now what happens here? So whenever this positive potential is given here, this maximum of all electrons can move towards the anode over here. So what happens? Photo current again increases only. So now again here the anode potential again increases one here. The potential again increases. What happens here? This photoelectric current is also increases only. That means here the photoelectric current is directly proportional to anode potential. Okay, suppose here when it reaches to maximum only, maximum. So that is equal to here saturation. So saturation photoelectric current here. So even though anode potential is increased here, the current should be remains constant. The current should be remains constant. So this is known as here the saturation photoelectric current. Saturation photoelectric current. So what is the saturation? What happens here? So whenever here the anode potential is increased here, the electrons can move from the cathode to anode. Photoelectric current is increased only. Again potential is increased here. So what happens again? The moment of the electrons is increased on here. So photoelectric current is also increased only. So photoelectric current is also increased. So it reaches again maximum. Okay, maximum. Again here the anode potential is again increased on here. So again increase means again here the photoelectric current should be remains constant. So whenever this photoelectric current should remains constant, even though anode potential increases. So this type of the current is nothing but saturation photoelectric current. Saturation photoelectric current. Okay. Suppose here so this one is equal to photoelectric current. Again, this one is equal to anode potential. So anode potential. So this one potential is equal to V. So what happens is this potential is increased here, photoelectric current is also increased one here, okay? Again, next one. Suppose at a potential is increased here, at this time what happens here? The photoelectric current should be remains constant only. So whenever it remains constant here, so this current is known as saturation photoelectric current. Saturation photoelectric current, okay? Again, next one, third point. Again, suppose K is equals on condition here, this anode is given by the negative potential. What second case, what happens here? The anode is given by the positive potential here. So now this anode is given by second negative potential. So anode is equal here negative potential. With respect to cathode, what happens? Cathode is equal, what happens? This is equal to here, this is positive potential. So that means here the collector is given by the negative potential, the emitter is given by the positive potential. Then what happens here? Just imagine the reverse on here. So this is equal again, this one is equal to negative one, this is equal positive one here. So what happens here again? Same as the previous example one here. There's persons coming from this first door over here, second door close, again they're opposing the person over here. So don't come to this door, don't come to. What happens here? The repulsion over here. Same here also, this one is equal to negative potential here. So all electrons can be repelled with this positive, repelled with negative potential. Okay, then what happens here? Again, whenever this negative potential is increased over here, what happens? Photoelectric current decrease only. Okay, again negative potential, again value again increases. This potential again the minus value is given here. So what happens here? At a particular time, at a particular potential, the photoelectric current becomes to 0. So that means what happens here? So whenever the negative potential first -5, -6, -7, minus, that means negative potential is increased only. What happens here? Photoelectric current also decreases only. At a particular negative potential of collector, the photoelectric current becomes to zero. So that is known as a negative potential. Suppose this one is equal positive side here, this negative side here. So this one is equal here, negative potential is equal to V naught. So negative potential V naught, this is all minus 1 here, okay, minus V naught, okay, this is a very important part, negative potential. So negative potential, zero potential also, zero potential only here. So what happens here? The negative potential of the anode for which the photoelectric current becomes what is the value? Zero. The photoelectric current becomes zero. So that is known as here the negative potential or retarding potential also. Okay, that is symbol is equal to minus V naught. So once again the definition of the negative potential or retarding potential. So what happens here? Negative potential, what is the definition here? The definition, the potential of the anode is decreased for which this photoelectric current becomes to zero. So the photoelectric current becomes to zero. So that is known as a negative potential. This negative potential again given to the kinetic energy of the maximum kinetic energy. Diagram is completed here. Again, it gives here so according to work energy one here, the work done by the negative potential is equal to change in kinetic energy. The work done by so negative potential on electrons, negative potential is equal to the work done by negative potential is equal to, so maximum kinetic energy of electrons. So one more point here, the work done by the negative potential is equal to, so maximum kinetic energy of electrons. So what is the work done equation here? So one topic will come into first this electrostatic here. So V is equal here the W by Q. So W is equal, what is that equation? V into Q. This is the one equation here. So V into Q. So V is equal to negative potential. So this one is equal to minus V naught. Again Q is equal to charge of the electron here. This is equal to minus E. So this is minus E. So maximum kinetic energy. So this one is equal to K E max. And K E max is equal to half mv square maximum here. Okay. So minus V naught into minus E is equal to K E max. Again, this is equal to here V naught into E, or E V naught is equal to here so half mv maximum square. So this is the one equation here. So E into V naught is equal to say, so E into V naught is equal to half mv maximum square. This is the one equation. Now I am going to explain so what about intensity of incident radiation? So what about frequency of incident radiation? So what about increasing the anode potential of this photoelectric current? Okay. So that is the important topic here. So what about this experiment is equal here? In our mind here, in our mind, first you have to study again how many parts are there in the experiment is equal here. Simply main is equal here the evacuated glass tube, or this is also here the quartz tube only. Okay, evacuated, completely cleared. Okay, this having the one window, again this one is equal like a transparent window W here. So this one is equal to filter. So what is the useful of this filter means here we are sending the different types of the frequencies on here. So minimum frequency, maximum frequency, changing the frequency also. So one is equal to blue light, second one is equal to violet, like this one here, different colors over here. Again W is equal to here transparent, again window. Again next one A is equal to here this is equal to here the emitter to emit the electrons, nothing but cathode only here, electrodes, okay, metal electrodes, okay, cathode. So A is equal again, A is equal to anode. This is also nothing but collector only here to collecting this all electrons from this metal surface only, okay, this one here. Okay, next one. So V is equal to potential difference between this anode and cathode one here. So this is equal to microammeter. Okay, next one. First again here, what happens here? Suppose in this circuit here, this battery is not there on here. What happens? This one. That means K is equal here the open and K is equals open only here. So K is equal open means what? This is not there only. What happens here? Whenever here the suitable frequency of incident light, suitable frequency of incident light is incident on this electrode. What happens here? So electrons are ejected. Same concept here. So what happens here? This all electrons are moving towards the cathode here? No. So which are the electrons here? Only here the high energetic electrons can move towards to the okay, I told one example. Which example here? The students coming from this door over here. So again here this door is closed here. So only high energetic person can jump from the classroom to ground over here. Since high energetic students over here. Not all students, okay? But don't do that jump over here. Okay, again, next one. So that means here the high energetic electrons can move towards the cathode one here. So due to movement of this high energetic electrons here, little bit amount of the current to process in this circuit one here. So this is known as here the photoelectric current, okay? Again, next one. Suppose after some time what happens here? This is completely filled with electrons only. So this VCM, this space is equal to space charge also, over here. So now what happens here? So this is equal to negative charge, this also negative charge, this also negative over here. So what happens here? This negative and negative repulsion over here, some of the electrons can reach us to the anode also, okay, this one. So now second point, so switch K, tap K is equal to here the on condition only here. So on means I can close it only. What happens here? Again, one more condition here. In this case here, this anode is given to the positive potential with respect to cathode only. With respect to cathode means here, so cathode negative automatically. So what happens? This is equal to positive potentially. This one is equal to negative. This is equal to negative one here. So what happens here? This all electrons can be repelled with this negative charge one here, and also this all electrons can be attracted with this anode one here. Clear again? So one side is equal repulsion here, one side is attractive one here. So from this door again, this person sending the students again here, one more person again attracting that to students one. What happens? The movement is there one here. So what happens here? This all electrons can move towards the another one here. So what happens here? Photoelectric current again increases only. Photoelectric current is increase. Again increase means what happens here? The potential is again increase one here. Potential is increase. Whenever the potential is increase here, photoelectric current is also increase only. Clear this one here? Again, sometimes what happens means here the photoelectric current becomes maximum. So even though this anode potential is increase only, So even though anode potential is increase, the photo current becomes to maximum, maximum. So this type of the current is nothing but a saturation photoelectric current, saturation, okay? Again, next third point here, this anode is given by the negative potential with respect to cathode. So what happens? This one is equal to negative, this is equal to again anode. So what happens here? This all electrons repulsion with this anode one here. So again, what happens here? The photoelectric current again decrease one here. Again, anode potential again this negative is increase here. At a particular negative potential of the anode, the photo current becomes zero. So this photo current becomes to zero is nothing but negative potential only. So that means here the negative potential of the anode is increase. So -5, -6, minus like this one. Okay, negative potential is increase on here. At a particular negative potential of the anode, the photo current becomes zero. So that potential is known as a negative potential. Again, next one. Again here the negative potential again this is equal to work done by the negative potential is equal here so maximum kinetic energy electrons one here. So what is the work done equation? One more equation here, it will come in so what is this electrostatics here? Potential is equal to W by Q. So W is equal to V into Q. So V is equal to negative potential. This one is equal to minus V naught. Electron charge is equal to minus E, which is equal to here so Ke max of MV maximum square. Okay. So again 0 also no need that one here. So E V naught is equal to of MV maximum square. This is the first equation. Okay now. Again, what is one more equation is equal to E is equal to H nu naught. Shall I stop here?